starts with a simple glance up at the night sky, that quiet glowing face we've always known as the moon, steady, peaceful, and constant. It's been up there for billions of years, circling our planet like a silent guardian. But what if one day that calm was shattered by something completely unexpected? Not an asteroid heading for Earth, but one barreling straight toward the moon. Imagine a colossal asteroid, a frozen rocky mountain drifting through the void, slamming into the moon at thousands of kilometers per hour. No warning, no defense, just a violent, unstoppable crash. It's the kind of impact that could leave the moon scarred forever and send shockwaves of chaos down to Earth. We always think about asteroids as threats to our planet, but what happens when they strike something just one step away? This is the story of what could unfold if the moon took the hit for us, and why that might not be the lucky break we think it is. Now picture the moment it happens. No sound in space, but from Earth, you'd see it. A blinding flash erupting on the moon's surface, bright enough to be visible even in the daylight. An asteroid, perhaps several kilometers across, crashes into the lunar crust with unimaginable force. In an instant, the quiet moon becomes the site of a cosmic-level collision. The blast unleashes more energy than every nuclear bomb on Earth combined, and then some. The moon's surface, already cratered and ancient, would be violently transformed. A new massive impact basin, possibly hundreds of kilometers wide, would be carved out in seconds. Superheated rock and vaporized dust, what scientists call ejecta, would shoot outward in every direction. Some of this material would escape the moon's weak gravity entirely, flung into space at speeds of several kilometers per second. The landscape would ripple with seismic shockwaves, likely fracturing deep beneath the surface and permanently altering the moon's internal structure. And remember, the moon doesn't have an atmosphere to slow anything down. Every bit of debris from this impact is raw, fast, and deadly. Towering plumes of dust would rise and fall in total silence, leaving behind a brutal new scar for Earth to see, a reminder of just how suddenly everything can change in the cosmos. But the real problem, what happens next, when all that material starts moving through space? Because not all of it is going to stay up there. Some of it is coming straight back to us. In the hours and days that follow the impact, Earth would begin to experience the real consequences. At first, the signs might seem beautiful, an extraordinary meteor shower lighting up the sky. But this time, those glowing streaks of light wouldn't be harmless. They would be the first wave of lunar debris racing through space and slamming into our atmosphere. The initial wave would mostly be smaller fragments, bits of vaporized lunar rock and dust, no bigger than pebbles. These would create a dazzling but dangerous light show, as countless particles burn up high in the upper atmosphere. Entire skies could glow for hours at a time, even during daylight. But this is only the beginning. Mixed in with the dust storm are much larger, heavier chunks, everything from rock fragments the size of baseballs to debris as large as small houses, and they would not all burn up. Earth's atmosphere can usually break apart smaller meteoroids, but bigger pieces, those could survive the fall. Hundreds, possibly thousands of meteorites would crash across continents and oceans. Most would not be big enough to cause mass extinction, but enough of them could cause serious destruction. Imagine random impacts flattening homes, sparking fires, or pummeling highways and farmlands. A single lunar boulder crashing into the ocean could trigger dangerous waves, or even regional tsunamis. Even beyond Earth's surface, our orbiting satellites would be at risk. The moon's debris cloud would be filled with tiny but fast-moving particles, fast enough to rip through metal. Communication networks, GPS systems, weather tracking, and surveillance infrastructure could all be knocked out. And since this rain of particles would continue for days or even weeks, the damage to satellites could be widespread and ongoing. The Earth wouldn't be hit all at once. This fallout would arrive in unpredictable bursts, creating fear and uncertainty across the globe. And the worst part? No one would know exactly where the biggest pieces might fall next. The impact that began in total silence on the moon would become a loud, chaotic, and potentially deadly crisis back on Earth. With Earth enduring the fallout, the long-term questions would begin to take shape. The moon itself, while still hanging in the sky, would no longer be the familiar, stable companion we once knew. Even though the moon is massive, far heavier than any asteroid that might hit it, an impact of this scale could still alter its behavior in subtle but serious ways. The odds of the moon being knocked out of orbit completely are extremely slim. Its mass is so great that even a giant asteroid, something the size of the dwarf planet Ceres, would barely budge its path. But not all changes would be dramatic. A high-energy impact could slightly shift the moon's axial rotation, or nudge its orbit just enough to disrupt the delicate gravitational balance it shares with Earth. These small adjustments might not be visible at first, but their long-term effects could be significant. Our tides are governed almost entirely by the moon's gravitational pull. If the moon were to lose a large portion of its mass, or change its position, even slightly, Earth's ocean tides could shift in unpredictable ways. Lower tidal ranges would hurt coastal ecosystems that depend on the rise and fall of water. Shorelines, wetlands, and estuaries, places where life has evolved over millions of years, would struggle to adapt. Sea creatures that rely on the moon's pull to breed, feed, or migrate could begin to vanish. And then there's Earth's tilt. The moon acts as a kind of cosmic stabilizer, helping to keep our axial tilt in check. Without it, or if the moon were to become much smaller or lighter, Earth could start to wobble. This wobble, over tens of thousands of years, would swing our planet's tilt from nearly 0 degrees to as much as 45 degrees or more. That might not sound extreme, but such a shift would totally change global climates. Regions that once had moderate seasons could face brutal winters or endless summers. Some areas might turn into deserts, while others would freeze year-round. Agriculture, one of the foundations of human civilization, could become almost impossible in certain zones. And over centuries, entire populations would be forced to migrate as Earth's climate reshaped itself in unexpected and chaotic ways. So while the immediate threat of the impact is terrifying, it's the slow unraveling of our planet's balance that could prove even more dangerous. The moon doesn't just light up our nights, it keeps Earth steady. Without that, the world we know could slowly start to drift into one we no longer recognize. As the years stretch beyond the initial chaos, the true scale of this lunar catastrophe would slowly start to reveal itself. While the bulk of the lunar debris might fall to Earth over days or weeks, the smaller particles, the fine moon dust blasted into space, could remain suspended in Earth's upper atmosphere for years. This high-altitude haze would scatter sunlight, possibly dimming the skies and dropping global temperatures in a phenomenon similar to what happens after major volcanic eruptions. This impact winter might not be as severe as one caused by a direct hit on Earth, but even a mild, persistent cooling could disrupt weather patterns and shorten growing seasons. Crops in some regions could fail, other areas might face unpredictable droughts or flooding. A few degrees of global temperature change is all it takes to shift ecosystems, forcing entire food webs to adapt or collapse. Farmers, already reeling from lunar debris, damage, and satellite disruptions, would now have to contend with a climate gone strange. Meanwhile, Earth's night sky would look unfamiliar, even haunting. A giant new crater would scar the moon's surface, visible even to amateur astronomers with backyard telescopes. If enough ejecta escaped the moon's gravity and got caught in Earth orbit, we could see something no one has ever witnessed, a faint ring system around our planet. Like a dusty halo, this ring would shimmer faintly in the darkness, changing how our nights looked and felt. It might even increase nighttime brightness temporarily, especially in areas already lit by city glow. But these rings wouldn't last forever. Over time, gravity and atmospheric drag would pull that material back down to Earth, causing sporadic meteor showers that could last for decades, maybe even centuries. For future generations, streaks of moon dust lighting up the sky could become a common sight, a recurring reminder of the day everything changed. And what if the impact had been even worse? Say if a massive section of the moon had broken off. The consequences wouldn't just be visual or climatic. Many nocturnal animals, tuned to the moon's light for hunting, navigation, and breeding, would lose a key environmental cue. Species could vanish simply because their world went dark. For humans, the psychological effect of a mangled or missing moon could be profound. After all, it has guided our myths, our calendars, even our sense of time and rhythm for tens of thousands of years. So even if Earth survives the worst of the physical damage, the moon's transformation would mark the beginning of a different kind of era, one shaped not just by altered tides or dimmed sunlight, but by the long shadows of a sky we no longer recognize. The moon would no longer be a silent guardian. It would be a monument to what could happen when cosmic forces collide in the wrong place at the wrong time. As the chaos begins to settle, Earth enters an unfamiliar chapter, one where daily life is shaped by an event no one alive has ever experienced. The dust storms clear, the debris showers lessen, and the skies begin to stabilize, but everything beneath them has changed. For billions of people, the priorities would shift quickly from awe to survival. With damaged infrastructure, collapsed food supply chains, and unreliable communication systems, countries would be forced to rebuild under new conditions. Emergency efforts would focus on stabilizing cities hit by falling debris, restoring power grids damaged by satellite outages, and relocating coastal communities grappling with altered tides. Agricultural zones may have to shift entirely, especially if the impact winter had any lasting effects on temperature and rainfall. In some regions, crop yields might plummet for several growing seasons, forcing mass migration and sparking political unrest. Nations would compete for fertile land, stable climates, and fresh water, all while navigating a disrupted global economy. Scientists and engineers would be racing to understand the moon's altered behavior. Even minor changes in its orbit or spin could have knock-on effects we don't yet fully understand. Predicting tides, tracking long-term climate patterns, and maintaining global navigation systems would become more difficult. For researchers, it would be an unprecedented opportunity to study planetary scale change in real time. For everyone else, it would mean adapting quickly or suffering the consequences. But the psychological aftermath might be even deeper. The familiar night sky, now permanently changed, would become a symbol of vulnerability. For millennia, humans have looked to the moon as a constant. Its phases guided ancient calendars, inspired entire mythologies, and acted as a silent witness to our history. Now that symbol would be cracked, possibly half-lit, maybe even orbiting a few degrees differently, always reminding us of just how close we came to something far worse. Culturally, this could spark a shift in human thinking. People might begin to take cosmic threats more seriously. Asteroid detection programs could receive major boosts. Governments might invest more heavily in space infrastructure, not just for exploration, but for planetary defense. Lunar colonies or off-Earth observatories could go from science fiction to global priorities. And the public, they'd likely become more attuned to the idea that Earth's place in the solar system is fragile, and that survival might require thinking far beyond our atmosphere. So even if life eventually returns to something like normal, it would never be that normal again. This kind of event wouldn't just reshape land or sky. It would change how we think, plan, and prepare. The moon's scar would become a warning. The solar system does not care about our schedules or civilizations. Its violence is ancient, random, and inevitable, and the next target might not be so distant. When the dust finally settles, literally and figuratively, the world would be left forever altered, not just by the damage, but by the realization of how closely we are tied to the moon. The final stage of this disaster would not be a dramatic explosion or a city-leveling impact, but a slow, sobering shift in human understanding. The moon was never just a light in the sky. It was, and still is, our stabilizer, our timekeeper, our shield. The crater now carved into it, or the pieces that may remain if it fractured badly, would become symbols of vulnerability on a cosmic scale. In this new era, Earth's rhythms could feel off. With altered tides, disrupted seasons, and unfamiliar skies, daily life would carry an eerie sense of imbalance. Generations raised with the full moon would now grow up under a dimmer, maybe broken celestial body. Lunar eclipses would no longer look the same. Entire cultures that built mythologies around the moon might have to reimagine those stories. Our calendars, once synchronized with the lunar cycles, could become increasingly detached from what remains of that rhythm. And if the moon had been shattered, beyond repair, if it became a field of debris instead of a single body, the consequences would stretch far into the future. Earth's orbit could accumulate dangerous clutter, making space exploration and satellite deployment more hazardous. For astronauts and space agencies, just getting into orbit could become riskier than ever. Nighttime would grow darker, colder, and emptier, especially in regions that once relied on moonlight for navigation, wildlife movement, and even agriculture. In a quiet but profound way, the world would become lonelier. But perhaps the greatest shift would be in how we view our place in the universe. A giant asteroid hitting the moon instead of Earth might at first seem like a lucky break, but in truth, it would show just how thin the line between safety and catastrophe really is. Earth didn't dodge a bullet, it just watched that bullet hit something it loves. This kind of event would change education, culture, politics, and science all at once. More people would push for asteroid defense systems. Funding for space weather forecasting and cosmic threat detection would explode. The idea of lunar colonies could transform from a scientific dream into a survival strategy. and many would start asking the bigger questions about existence, randomness, and how to plan for threats that come from far beyond our atmosphere. In the end, a giant asteroid hitting the moon would not be a problem we could simply clean up and move on from. It would be a defining moment in Earth's history, a cosmic lesson in fragility, a planetary reminder that, in the vast, unpredictable arena of space, we are not spectators, we are participants. And as long as we look up at the sky and see that altered moon, we'll be reminded that the universe is still writing its story. The only question is whether we're ready to read the next chapter.